Hi students, welcome to physics A level class, and today we are going to discuss the previous year question paper of October 2021 for the unit 1, and it is the part 3 video. Okay, we are going to the question number 14. A student carried out an experiment to determine the Young's modulus of a sample of stainless steel in the form of wire. The student added the weight to the wire and measured the corresponding extensions. The wire had an unstructured length of 2.6 meter. The diameter of the wire was 5.6 into 10 to the power minus 4 meter. The student plotted a graph of weight against extension. The graph showed that the limit of proportionality was not exceeded. Okay. The first part state what is mean by the limit of proportionality. Okay. Actually, this question is based upon the load and elongation of a metal wire. Okay. So, first of all, we have to answer what is mean by limit of proportionality. Okay. Limit of proportionality we can define from the word meaning itself. That means the applied force is directly proportional to the extension. Okay, that is the actual meaning of the limit of proportionality. Okay, so we can define it as the maximum value of force for which the force is proportional to the extension, that is changing length. Okay, the point beyond which the Hooke's law no longer applies. Okay, up to this point, up to the proportionality limit, we can uh, apply the Hooke's law. Okay, Hooke's law is nothing but the stress is directly proportional to strain or the force is directly proportional to the extension. Okay, these two statements we can use for Hooke's law. Okay, then now we can discuss some important characteristics points of a stainless steel. Okay, it is a graph between stress and strain. Okay, stress and strain, or we can the similar graph can be drawn between the applied force and extension. Okay, there are some points A, B, C, D, E, etc. Okay, then we can discuss what are the different importance of each point. Okay, so first of all, we can discuss the point A. What is the specialty of point A? The point A represents the limit of proportionality. Okay, slide beyond this point, the metal may still behave elastically. Okay, the metal may have the elastic property, but the stress is not directly directly proportional to the strain. Okay, in other words, we can say that applied force is not directly proportional to the elongation. Okay, that's the point. The specialty of point A, that is limit of proportionality. Okay, then what about the point B? The point B is nothing but it is the elastic limit. That means up to this point, the body have a tendency to regain its shape. Okay, while we remove the applied forces. Okay, beyond this point, the material is permanently deformed and will not return to its original size and shape. Okay, that's the importance of elastic limit. Okay, then whatever the point C, it is the yield point. Beyond this point, the material undergoes sudden increase in extension as its atomic structure is significantly reorganized. Due to the reorganization of its atomic structure, after the yield point, the material will elongate sudden extension of material taking place. Okay, then what about the point D? The point D represents the highest possible stress within this material. This is called ultimate tensile stress. Okay, ultimate point or maximum stress that can be withstood by this material. Okay, then point E, it is a fractured stress or breaking stress. Okay, it is the value that the stress will be in the material when the sample breaks. Okay, this stress or the force applied. Okay, or the force applied in the material when the material just breaks. Okay, these are some important points related to the force elongation graph or stress strain graph of a stainless steel. Okay, Now, the student's graph is shown below. It is based upon the question 14 itself. Okay. In y-axis, they plot the weight applied, and the x-axis, they plot the extension of the wire. Okay. Now, we have to determine the gradient of the graph. Okay. What about the gradient of graph? In order to find the gradient of graph, we have to draw a triangle. Okay. A triangle which should have the maximum size. Okay. So, it's perpendicular side shows the delta f, that is the force applied, and its horizontal side represents the elongation. Okay, so we can find out the gradient is delta f by x. Okay, which is equal to the force difference in force is equal to 40 newton minus the 40 newton minus 0 newton. Okay, divided by the extension force. What about the extension force? The extension force is from we this point. Okay, what about this point? This point, its value is nothing but it is 2.15. Okay, this is the third point. It is 2.15. Okay, 2.15 into 10 to the power minus 3. That much is the elongation. 10 to the power minus 3 minus, then the initial point is 0. Okay, so we will get the delta f by delta x is equal to 18.6 into 10 to the power 3 newton per meter. Okay, this is the value of gradient. Okay, now then next to your question, that determine the Young's modulus of stainless steel using your value from the gradient. Okay, first of all, we should know what you mean by Young's modulus. Okay, Young's modulus is nothing but it is represented by the letter E. It is a ratio of stress and strain. Okay, stress and strain. Where stress is nothing but is a force by area, and strain is nothing but is a change in length by original length. Okay, that is the definition of stress and strain. Okay, applied force by area is stress. Change in length, elongation divided by original length is strain. Okay, then the ratio of stress and strain is called a Young's modulus. Okay, so from this expression we can find the value of Young's modulus. Young's modulus is equal to the force by area or divided by delta x by x. Okay, so we will get, what about it is f into x. Okay, then division, division of fraction nothing but it is a multiplication with the reciprocal. Okay, so f into x divided by a into delta x. Okay, so by just rearranging this, we will get the Young's modulus is equal to f into x divided by delta x into a. What about the f? F is the applied force, x is the original initial length, delta x is the change in length, and a is the cross-sectional area. Okay. So, but we know that the value of f by delta x is nothing but it is a gradient from the graph, f by delta x. Okay, it is a gradient from the graph. It is equal to 18.6 into 10 to the power 3 Newton per meter. Okay. Then what about the unstructured length? It is also given in the question. Okay, unstructured length x is equal to 2.6 meter. Okay, then area of cross section, how we can find, since it is a wire whose cross section is a circular shape, so area can be found by using the equation pi r square. Okay, but they are given the diameter. Okay, they are given the diameter, so the radius is equal to diameter by 2. That's why we are putting uh, instead of r, it is 5.6 into 10 to the power minus 4 divided by 2. Okay, 5.6 into 10 to the power minus 4 is the diameter of the wire. Okay, divided by 2 whole square. So we will get the area of the wire. Okay, area of cross section of wire, a is equal to 24.63 into 10 to the power minus 18 meter minus 8 meter square. Okay, so now we can find the value of Young's modulus. How we can find Young's modulus is equal to f by delta x. Okay, f by delta x into x by a. Okay, that is f by delta x into f by delta x is nothing but is a gradient. Okay, it is a gradient, and into the original length divided by area of cross section. Okay, Then F by delta x is 18.6 into 10 to the power 3. Okay. Then the original length is 2.6 meter, and the area of the cross section is 24.63 into 10 to the power minus 8 meter square. Okay. By calculating this, we will get the Young's modulus as 1.96 into 10 to the power 11 Newton per meter square, or this Newton per meter square can be written as Pascal. Okay, the Pascal is nothing but it's a Newton per meter square. Okay, so Young's modulus can be written as 1.96 into 10 to the power 11 Pascal. Okay, then the next part. The breaking stress for the stainless steel is known to be 480 megapascal. Deduce whether it is safe for the student to increase the weight to 100 Newton. Okay. Then first of all, we know that that's what about the stress? Stress is sigma, which is equal to force by cross-sectional area. Okay. Then how we can found the breaking stress? The breaking stress is nothing but it is the ratio of breaking force by area. Okay. Okay, so we can found easily by the breaking force. What about the breaking force? It is the product of breaking stress and area. Okay, breaking stress and area. But here we know that the value of breaking stress. What about the breaking stress? It is the breaking stress is equal to 480 megapascal. Okay, 480 megapascal. That is in whatever the SI unit, 480 into 10 to the power 6 Pascal. That's the SI unit. Okay, Pascal means Newton per meter square. Okay, so we know the value of maximum breaking stress and the area of cross section. So we can find out the value of breaking force. Breaking force is equal to 480 into 10 to the power 6 Pascal into then whatever the cross sectional area. It is already we calculated in previous part. That is 24.63 into 10 to the power minus 8 meter square. Okay, so we will get the breaking force as 190 Newton. Okay, here in this question there says that the weight the applied weight is 100 Newton, and we know that the breaking force is 190 Newton. Okay, then how we can uh, reply to this statement, that is whether it is safe or not. Okay, since the applied force is less than the breaking force, the application of weight up to the 100 Newton is it is a safe load. Okay, so we can conclude that since the applied force is less than the breaking force, the application of weight is it is safe. Okay, it is safe. Question 15. The photograph shows a toy car that contains a spring. Pulling the car backwards along the floor compresses the spring. Energy is stored in the compressed spring. The car is released and the spring returns to its original state. There is a forward force on the car from the floor and the car moves forwards. Explain why the floor exerts the forward force on the car and how this force affects the motion of the car as the spring returns to its original state. Okay, that means initially we are moving the car in backward direction, and the spring becomes compressed. Okay, if we are considering it is a spring, then the spring becomes compressed, right? It is compressed. Then there is some elastic strain energy stored. Okay, then what happens in when we are just released, what happens then? The compressed spring have it due to the stored elastic energy. The compressed spring then starts to elongate. Okay, that means that the in forward direction we will get a spring force which is equal to k into x, right? Spring constant into displacement. Okay, right? Then we will get a restoring force. Okay, we are due to the restoring force in the spring, we get a forward motion. Okay, there is a force due to this resultant force in forward direction. What happens? The this Our car will trying to move. Okay, trying to move means there's due to this forward force, resultant force due to the spring, our wheels exert a frictional force on there exists a frictional force between our wheel of the car and the floor. Okay, This frictional force, according to the third law of motion, what happens if there is an action, there will be equal and opposite reaction. Okay, due to this frictional force between our tire, our wheel and the floor, uh, the the floor exert a opposite force, a forward force on what, on the wheel. Okay, so that's why the our car moves in forward direction. Okay, it's absolutely due to the reaction force which exert by the floor on our wheels or on our vehicle. Okay, due to that our car moves in a forward direction. Okay, then we know that the resultant force, that is absolutely due to the spring force. Okay, it is absolutely due to the spring force. And as the spring, as the car moves in forward direction, the compressive force stored, the compressive force in the spring is reduces. That means the acceleration reduces. Okay, acceleration reduces. At the ending point, the acceleration becomes zero. Okay, that means the spring is restored is the equilibrium position. Okay, as the spring restored its equilibrium position, what happens, our acceleration of the body becomes zero and there is no forward motion. Okay, so these total phenomena we can conclude as the following points. Okay, there is a backward frictional force on the floor from the wheels of car due to the compressive force of spring. Okay, there is a backward frictional force. Okay, then according to Newton's third law implies the forward force. That means uh, due to the frictional force is acting in reverse direction, or the reverse direction due to the applied force in reverse direction, or due to the frictional force in the reverse direction. According to Newton's third law, the opposite to the frictional force, we will get a force. Okay, we will get a forward force in the vehicle due to the Newton's third law. Okay, that's absolutely from the reactive force from the floor to the vehicle in forward direction, because the frictional force is acting reverse direction or the backward direction. Okay, the compression of the spring reduces as the car moves forward. Okay, as the car moves in forward direction, the compression of the spring reduces, that the resultant force becomes decreases. Okay, then the resultant force is proportional to the compression of spring. Okay, that means as the compression reduces, the resultant force is also reduces. Okay, the acceleration is proportional to the resultant force. We know that the resultant force is equal to mass into acceleration according to the Newton's second law. Okay, right? That means finally the acceleration reduces and it becomes zero as the distance star increases. Okay, as the distance increases, the acceleration decreases. Okay, finally the acceleration is zero once the spring has returned to its original state. Question 16. An explosion projects a rock into the air with a speed of 50 meter per second at an angle to the horizontal of 40 degree. Okay, show that the rock would reach its maximum height about 3 seconds after the explosion. Okay, from this picture it is clear that the motion of the rock can be treated as a motion of projectile, right? It moves in a two-dimensional direction, two dimensions. That means the rock covers in displacement as well as it covers the horizontal displacement also. Okay, so we can just consider it's a vertical motion. Okay, the complete vertical motion of the rock. Okay, we can consider vertical motion of the rock. Okay, then we know that the initial velocity can be resolved into two components. Okay, the initial velocity can be resolved into two perpendicular components. Okay, how we can resolve it? Okay, since the horizontal component makes an angle theta or 40 degree, if it is making an angle theta with the horizontal, if the initial velocity is u, then the horizontal component is u cos theta, right? In horizontal component is u cos theta, and the vertical component is u sine theta. Okay, so we can resolve this velocity into two components, one horizontal component and another vertical component. Okay, now we are considering the vertical, only the vertical motion of rock. So we have to consider the initial velocity of the initial vertical velocity of the rock, final vertical velocity of rock, acceleration of rock, etc. Okay, then what about the initial vertical velocity of the rock? It is the vertical component of the initial velocity, that is u sine theta. Okay, so the initial velocity of the rock in vertical direction is equal to u sine theta. Okay, we can find this value. Okay, they already given the initial speed. Okay, initial speed is equal to 50 meter per second, and we know the value of theta, that is 40. Okay, that is 50 into sine 40. You will get the value as the initial vertical velocity as 32.14 meter per second. Okay, then now we can find out vertical acceleration. Okay, actually the rocks move in a vertical upward direction, which is just opposite to the acceleration due to gravity, which is just opposite to the weight of the rock. That means opposing the gravitational force of the earth. Okay, that's why we are taking the acceleration as negative g. Okay, it is just opposite to the direction of gravitational force of earth. Okay, so we can take the acceleration in vertical direction as minus 9.81 meter per second square. Okay, so the final vertical velocity or velocity at the maximum height is equal to 0. Okay, then why it is 0? When the rocks attains the maximum height, then there is no vertical velocity. Okay, but it has some horizontal velocity. The horizontal velocity remains constant, which is equal to u cos theta. Okay, and its vertical velocity becomes 0. Okay, vertical velocity becomes 0 at the maximum height. Okay, then that means the rocks will move downward direction after reaching the maximum height. Okay, so the vertical velocity of this rock at the maximum height, vertical velocity becomes 0 at the maximum height. Okay, that is vy equal to 0. Okay, then now we have to find out the time required to reach the maximum height. Okay, that we have to find out the time. Okay, now we can recall the equations of motion. That is, for a uniform accelerated motion, we know the different equation: v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. Okay, by knowing these quantities, that is uy, ay, vy and t, which equation we have to prefer? Okay, we have to prefer v is equal to u plus at. Okay, from this equation we can easily find out the value of time required to reach the maximum height. Okay, so vy is equal to uy plus ay into t. Then substitute vy is equal to 0, uy as 32.14, and the acceleration is minus 9.81 and into time. Okay, by resolving it, by solving it, we will get 0 is equal to 32.14 minus 9.81 into t. Okay, then taking this part into left hand side, that is the negative terms becomes positive when they are coming in left hand side. We will get 9.81 into t is equal to 32.14. Okay, 32.14. Then easily we can found the value of t is equal to 32.14 divided by 9.81 is equal to 3.18 seconds. Then the next part, the rocks moves in the direction of hill. The side of the hill is at 20 degree to the horizontal as shown. After certain distance, the rock lands on the side of the hill. Deduce whether the rock hits the ground before it reaches its maximum possible height. Okay. Actually, now there is a hill, and the hill is an angle 20-degree inclined with the horizontal. Okay. So we will get this shows the hill. Okay. And now we have to find out that the rock hit the hill, is it before it's achieving the maximum height or after it achieving the maximum height? Okay, how we can find, or how we can uh, uh, explain this phenomenon. Okay, this one we have to find first of all the maximum height achieved by the rock. Okay, how we can find out? By considering the vertical motion of the rock itself. Okay, by finding the maximum height of the rock by using the vertical motion of, okay, vertical motion of the rock. Okay, then we have to find out the height of the hill corresponding to that um, maximum height. Okay, then corresponding how we can find the height of the hill. Okay, it is up it can be find out by considering a triangle, a right angle triangle. Okay, right angle triangle, and whose base is nothing but it is a horizontal distance traveled by the rock in a time which is corresponding to reaching the maximum height. Okay, so we can represent the capital H as the maximum height of the rock achieving. Okay, maximum height achieved by the rock, and small h is the height of the hill corresponding to the maximum height of the rock. Okay, maximum height achieved by the rock. Okay, so and x is nothing but it is the horizontal distance traveled by the rock corresponding to a time which is consumed by the rock to achieve the maximum height. Okay, then maximum height of the rock, maximum height achieved by the rock is capital H, and the height of the hill corresponding to that point is EH. Okay, and now we are considering a triangle ABC. Okay, first of all, we are considering the vertical motion of rock. So this problem can be split into three steps. First, consider the vertical motion of rock, right, and find out the maximum height. Okay, right. Then we have to consider the horizontal motion and find the distance traveled by the rock in horizontal motion, that is x. Then consider the triangle ABC, and by using trigonometry we have to find the height EH. Then compare these two heights. Then we can find or we can explain this question. Okay. First of all, we are moving to consider the vertical motion of the rock. Okay. Vertical motion, what about the initial velocity? In vertical direction, the initial velocity uy is equal to 32.14. We already know. Okay. Then what about the acceleration in vertical direction? In vertical direction, the acceleration is minus 9.81 meter per second square. And we know that the time required to reach the maximum height equal to 3.28 seconds. Okay. Also, we know what about the maximum displacement in vertical direction. It is the maximum height EH. Okay. Then by using the equation Sy is equal to, that is S is equal to ut plus half at square. We can use this expression in vertical motion, that is Sy is equal to ut plus half uyt plus half into ayt square. Okay. That is, we know that the Sy is equal to EH, uy is 32.14, time is 3.28, and half into the acceleration is minus 9.81, and time is equal to 3.28 seconds. Okay, by substituting these values in this equation we will get the maximum height. Okay, what about the maximum height? Maximum height is equal to 52.65 meter. We got the value of maximum height achieved by the rock as 52.65 meter. Okay, then now we are moving to considering the horizontal motion at the same time of achieve at the during the same time which is consumed by the rock to achieve the maximum height. Okay, that is consider the horizontal motion. What about the initial velocity in horizontal motion? Initial velocity ux is equal to u cos theta. Okay, and ux is equal to u means 50, and theta is 40 degree. So you will get the initial velocity in horizontal direction is equal to 38.3 meter per second. Okay, and what about the acceleration in horizontal direction? There is no acceleration in horizontal direction, so ax equal to 0. Okay, and the time required to reach the point x, it is nothing but t is equal to 3.28 seconds, the same time as required to reach the maximum height. Okay, that is the time t is equal to 3.28 seconds. Okay, by from this expression we know that s is equal to ut plus half at square. We can apply this equation to the horizontal motion. Sx is equal to ux t plus half into ax t square. Okay, then we know that the ax equal to 0. Since the ax equal to 0, this complete part turns to 0 since ax equal to 0. Okay, so you will get, uh, we know that the sx means the horizontal distance is equal to x. Okay, horizontal displacement is equal to x is equal to initial velocity in horizontal direction into the time required. Time is equal to 3.28. Okay, so we will get the x is equal to 125.63 meter. Okay, now we are going to consider the triangle ABC. Okay, and apply the geometry. Geometry means we have to consider that we know that the tan theta is equal to opposite side divided by adjacent side. What about the opposite side of triangle ABC? The opposite side of triangle ABC with respect to the angle 20 degree is h, and the adjacent side is x. Okay, so if you are taking the tangent of 20 degree, tan 20 is equal to opposite side h divided by adjacent side x. Okay, from this expression we can find out the value of h. What about the h? H is equal to x into tan 20. H is equal to x into tan 20. Okay, that is h is equal to, what about the value of x? We already know the value of x, that is 125.63 into tan 20. Okay, which is equal to h. So we can easily find out the value of h is equal to 45.73 meter. Okay, now we can compare these two values. Okay, the maximum height achieved by the rock is 52.65 meter, and the corresponding time and the corresponding height of the hill at the same time is equal to, or at the same point is only 45.73. Okay, so what we can conclude, that is, since the maximum height is greater than the height of the hill, it does not hit, the rock does not hit the ground before it reaches the maximum height. Okay, for initially the rock achieve the maximum height, and then only it hit the ground. Okay, so thank you so much.